Hello and welcome to our SOL review of 8.10 box and whisker plots. So what we're going to do is talk a little bit about what a box whisker plot is, run through this graph I have, and go through an example. I think it's really vital, once we label everything, to really pause and study the box and whisker plot. You really want to make sure you understand what each of these little marks means, or the box, and also the percentages we're going to get into. So here we go. Box and whisker plot is basically broken up into 4 sections, and it's broken up into basically 5 terms. So with the set of data, any set of data, there's a minimum and a maximum. Now a minimum is usually referred to as the lower extreme, and it's located at the far left of the box and whisker plot. We also have the maximum, also known as the upper extreme, which would be up here at the top. So our minimum for this problem would be 10, and our maximum would be 55. Okay. We also have the median, which is the middle. Now, a lot of students like to confuse median and mean and mode. Mean is the average of all the numbers. It's where you add up all the numbers and you divide it. Median is the middle number of the data set. So if you have 9 numbers, it would be the 5th number in the data set. So box and whiskers almost doesn't even actually care what the numbers are, it just cares how many numbers there are. Lower quartile. This is sometimes referred to as the median of the lower half of data. So Q1 is actually right there, and Q3, the upper quartile, is located up there. Now, you might be hearing this word quartile for the first time. You might be thinking, wow, quartile sounds a lot like quarters, and that's because it's exactly where it comes from. Each of these sections represents 25% of the data. So even this little small section here and these 2 longer sections, each one is 25% of the data. This is really important to remember for certain questions like below. It says, if total number of entries was 20, how many are above 20? Okay, so let's go ahead and go to 20. So 20 is right here. And that's 1, 2, that's 75% of the data is above 20. So you would do 20 times 0.75, which that would tell us that's 15 numbers above Q1. And that's really helpful because sometimes you're going to have to do that and figure out, hey, how many data points are above or below a certain number without actually being given the data set. So if you just remember that each section is worth 25%, that'll help you tackle that problem. Like I said earlier, I want to remind you, I think it'd be a really good idea to pause the video at this time and just kind of really try to memorize a couple of these terms, and definitely the percentages. That's going to help you a long way. Let's go ahead and take a look at an SOL problem. So I'm going to zoom out a little bit here. Ooh, gotta keep zooming. A study was conducted to determine the number of cars that pass through 2 intersections each for 20 days. The results are summarized in the box and whisker plots below. Which statement is best supported by this data? So, just a little refresher. The medians are right here, so there's the one for intersection 1 and 2. The minimums are there. Maximums are there. There's one other term we didn't talk about which might actually come up, and I want to bring it up. Range and interquartile range. So range is the maximum minus the minimum. And so all I would do for something like this, like 550 minus 350, the range of intersection 1 would be 200. The interquartile range, that is the upper quartile, so Q3, minus the lower quartile, Q1. So just remember, the range is the max minus the min, and the interquartile range is just the range of the box, part of the box and whisker plot. Alright, so let's go ahead and tackle this now. So which statement is best supported by these data? So A, the range of the data for intersection 2 is twice the range for the intersection 1. Alright, let's check it out. So let's call it range of 1. So the range of the intersection 1, 550 minus 350, that's 200. And the range of intersection 2, well, that's 650 minus 250. And that would be 400. And the question said, the range of the data for intersection 2 is twice the range of the data of intersection 1. Well, that's actually true. So the answer is already there. But let's go ahead and just go through the other ones, just kind of more box and whisker review. The lower quartile for intersection 1 is greater than the lower quartile of intersection 2. Well, here's the lower quartile of intersection 1, and here is the lower quartile of intersection 2. So as you can see, the section for 1, the lower quartile for 1, is less than the lower quartile for intersection 2. But they wanted the phrase greater, so therefore that wouldn't be true. The interquartile range for intersection 1 is the same as the intersection. Okay, let's take a look. The interquartile, so I'm going to go ahead and use an abbreviation for this. I'm going to use IQR, which would stand for interquartile range. So the interquartile range 1 is 550 to, it's kind of in between data, so we're going to go ahead and guesstimate. We're going to call that 375. So it's 500 minus 375, which that would just be, let's see, 125. And let's go ahead and do IQR of number 2. Alright, so the second one would be 550 minus 400. That is 150. The question said that they were the same. No, they're not the same. And you can actually even kind of visually tell that the box portion of intersection 2 is slightly bigger than the box portion of intersection 1.